Good evening. Today we're going to go over how atomic and hydrogen bombs work. So, there are two main types of weapons of mass destruction, and they are the atomic and hydrogen bombs. Usually, in this little drawing I have, they are shaped like a little torpedo almost. It's very basic looking, but the shape of it doesn't really have too much to do with their mechanisms. Um, so, in order for us to understand the difference between the two bombs, we need to analyze the mechanisms of each. So we'll start off with the nuclear explosion. And for a nuclear explosion to happen, um, there needs to be a heavy nuclei fission. And there are several elements capable of a heavy nuclear reaction. Heavy nuclei fission basically means it's an element with a large atomic mass. The most commonly typed used is uranium 235. They also use uranium 238, and sometimes uranium 234 is used. And it's important to note that all three are isotopes of uranium. Um, in order to achieve maximum damage with uranium, the content of the 235 uranium isotope should be over 80%. Um, and as a result of that requirement, further enrichment of the uranium must be accomplished through a very difficult process. Additionally, if you're not able to enrich uranium, you can make a plutonium bomb. And the most common isotope for plutonium is plutonium 239. But plutonium is really rare in the natural world and must be made in a lab. So that's why uranium is used more often for atomic nuclear bombs. So by themselves, this isn't going to create an explosion. So there has to be a certain mass of fizzled materials concentrated in one place, and this mass is also known as a critical mass. Um, in a normal nuclear bomb, there's usually 4 or 5 critical masses, and so we can use the analogy of a ball to demonstrate a critical mass. So you have the unreached critical mass. So in the center is the different critical masses on the sides of the ball. So this concept is also known as implosion. Um, so in the first stage, you have an unreached critical mass, and then you perform a guided explosion, okay, which it could be as simple as an explosion from the outside of the ball. And what happens is the space within inside the ball will start getting closer to the center of the shock wave, creating a nuclear decay reaction. As you can see here, they all come closer. As a result, the density of the uranium or plutonium core increases and you get an explosion, essentially. Now we move on to the hydrogen bomb, and a hydrogen bomb is mainly accomplished through thermonuclear fusion, which is a very fast sequence of reactions. Elements such as deuterium and tritium, which are isotopes of hydrogen, are used inside a thermonuclear fusion, as well as lithium hydride. On their own, these effective substances will not cause a thermonuclear reaction, though. They need a detonator, otherwise known as a integrated nuclear device. Now, the power of nuclear and hydrogen bombs are can be quantified, and they are usually measured in TNT equivalents. They could be, however, tons of TNT needed to be exploded to equal the destructive force of one of those bombs. Um, One of the most famous hydrogen bombs is the Tsar Bomba. Um, and another interesting thing about these bombs is they produce various types of radiation. There's three types of radiation. There's alpha, beta, and gamma. Alpha are pretty much harmless. Your clothes can protect you from alpha radiation. But beta is a little bit stronger. It produces radiation burns, and gamma is extremely penetrative. The only thing to stop gamma rays would be a layer of thick lead, for example.